Project 66 is persistence of vision. This project gets pretty interesting. We will use this circuit, plus we will insert the fiber optic cable on the white LED, just one end of it, using the black holder here. We will place the cable as far in as it will go. Make sure that the black cable holder is on steadily, is on tightly. And we will move the RV lever toward me and turn off this light. You can see how the fiber optic cable is lit up. Now I have to be careful and make sure that the cable doesn't slip out of its holder. But the other end will obviously remain out. And we will wave it back and forth in the air. Now what do you see as I wave the cable back and forth rapidly? You probably see a series of long dashes and not a single speck of light or a continuous line of light. I will now adjust the lever on the RV and move it about mid-range. That's where I think that's about mid-range. What do you see now? Now you see more dots instead of dashes. Lastly, move it on the lowest setting. And actually I was pretty close to there. But the dots are even smaller. The reason why you may see this light as dots or dashes is because of how your eyes are perceiving the light. Even though technically it's just a small dot of light, when you wave it rapidly, your eyes perceive that light as dots or dashes in this case. I'm going to turn this light back on. A good example of persistence of vision is in a movie theater. And a movie that you might be enjoying consists of a lot of still pictures, but the frames or individual pictures are flashed on the screen with a projector at a fast rate, usually 24 frames per second. That's 24 pictures per second. And they're going so fast through the projection system that the pictures appear to be one continuous video or movie. So in a nutshell, that's how movies work. But the waving of the fiber optic cable is another good example of how your eyes perceive light that moves or changes rapidly. Project 67 is prismatic film. We use the same circuit as we did in the first project in this kit, but we will be looking at the color LED through the clear prismatic film. As I may have told you in the intro to this kit, there are different prismatic films that are included, and we are going to use the white one, the clear one. I'm going to turn on the color LED. And the camera might see the LED as glary, but do you see any different interesting color patterns as I move the prismatic film closer and further away from the color LED? It's pretty spectacular, isn't it? That's because this type of film is separating the light into different colors. So you only see either blue, green, or red at one time, usually. Now we can replace the color LED with the white LED and then the red one. Here's the white LED. Oops. Now it's pretty bright, but you can probably see the colors of the rainbow because white is made up of all colors, as what Snappy says right here. And then we can do the red LED. And you just say red colors because red is a primary color, so it cannot be divided into separate colors. If you use the cyan LED, for example, I think you would get yellow and blue. Although I could be wrong about the color combination. But this is how the prismatic film works. Project 68 does not actually require a circuit, but this project, called Look at the Lights, requires you to view different light sources in and around your home through the prismatic film. I'm going to start with this desk lamp, and it may be tricky, so I'm going to move a distance away, but do you see anything unusual as you look at the desk lamp through the prismatic film? You can see a rainbow reflected by the light, and that's because the light is white, but when it's broken up, you can see all the different colors that produce white. Now we're also going to do this other floor lamp here, and likewise you say different colors of the rainbow because the lights alone are white even though the housings are different colors. And one of the lights is burned out, so I can't use blue, but I can quickly go over and see the patterns that are produced by the different color housings. You still see a rainbow patterns, but it's best to view the actual bulb through the film and not the housing because that's the actual light source. And those are the only light sources I can use right now in my room, but feel free to view different ones in your own home. Project 69 is scattering light. We're going to use the same circuit as in Project 67, but instead of viewing the color LED through the prismatic film, we're going to view it through various translucent surface materials, such as this plastic bag, this snow globe, and this other translucent plastic bag. So here we go. We're going to see whether the light will be scattered. Do you see any differences in how the light is scattered with the transparent plastic bag? How about the snow globe? The snow globe seems to scatter the light a lot, even though it is completely over the LED. Now we're going to use this translucent bag. But it doesn't seem like it scatters the light too much, even though it lets some of it through. However, you can see the separate colors more easily. At least when the LED is flashing, you can see how the color LED consists of a separate red, green, and blue LEDs because of the way the bag is scattering the light. Now we can do the same experiment with the white LED, and I'm going to quickly use the three different materials, white, it seems to scatter the light a bit. Oh, it really scatters the white light too. And now we're going to do the translucent bag. It does seem to scatter the light a little bit, but semi-transparent materials like these scatter the light without completely blocking it. And so a wide area of that material or liquid is lit up by the light. And this is the case with the egg and tower attachments that you can put over the LEDs in this kit. They're holding in a lot of the light, so it's more scattered. Project 7D is called Color Fiber Light. We're going to use the same circuit, but we are going to insert the clear fiber optic holder on the color LED, and then insert the fiber optic cable inside of the holder as far as it will go. And then we will turn on the slide switch, and it's recommended that you do this in a dark area. I'm just going to do it here, and even when you bend, you can see how the color light is transferred through the fiber optic cable. Even if you bend the cable a lot, like I am now, I bend it into a loop, the light still goes through pretty easily. And this reflects about how fiber optic cables transfer light in earlier projects that I demonstrated. You can see right there. Project 71 is one-way plastic. This project is very unique in that we are building it without the base grid. But we are going to use the base grid for this project, and in a different way. We will turn on the color LED, it flashes, and then we're going to hold the base grid over the color LED, and you notice how it is transparent and you can easily see through it. But now we're going to tilt the base grid on its side, and this is going to be a little bit tricky, but we're going to try view the LED through the side of the base grid, which is supposedly clear. Do you see it? Can you see the LED through the base grid? You cannot. Why is that? Why can you view the color LED through the front or back of the grid but not the side of it? That is because the main surface of the base grid is flat and smooth, and it gives you a nice transition for light rays to pass through. But if you look closely at the side edges, and you should use a magnifying glass for a better idea, you will notice that they are slightly curved. And these curves and the angle of the light hitting them cause more light to be scattered or reflected than light hitting the main surface. And so some materials can also pass light better in some directions than in other directions because of their physical structure. 72 is white blinker. For this project, we are using both the color LED and the white LED. We will turn the circuit on, and let's see what happens. The color LED blinks, but so is the white LED. Why is that? Well, the color LED has a microcircuit that changes its colors. And as it does this, it is also controlling the current that goes through the circuit, and therefore it's affecting how the white LED performs. The current is causing the white LED to change brightness and flash as well. 73 is red blinker, and I just replaced the white LED with the red one. Turn on the slide switch, and while it may be hard to notice, the color LED is still controlling the red one, and it is changing brightness and blinking too. It's the change in brightness is less notable with the red LED, but you can easily see it blink, because once again the color LED is controlling the current. Project 74 is red and white. we will use the preceding circuit, but replace the color LED with the white LED. We will turn on the slide switch. Both LEDs come on, but neither of them are blinking. And that's because these LEDs do not have micro circuits to control their brightness, and so they will be on steadily. Project 75 is Color Selector Red. This project, along with the next 6 ones, will focus on the individual colors on the color organ and how they appear when viewed using the fiber optic tree and the clear plastic slide. We're going to turn on the slide switch. We're going to see how the LED looks but when we use the fiber optic tree. Now the camera may pick up some yellow in addition to red, but it's really solid red. Now we're going to remove the fiber optic tree in its holder, and the LED, now you see just the plain LED. Hold it through the slide, and it looks like the light is scattered pretty good. As you zoom in, the more you zoom out, the more the light is scattered. The more you zoom in, the more concentrated the light is. These kinds of surfaces are good at breaking light apart. Project 76 is Color Selector Green. We're using the same circuit. We're going to use it in all these projects, but we're going to move or add 2 snap wires. We're just moving this one to these points here, C and D. These were points A and B. We're going to turn on the slide switch. Now the LED is green. The fiber optic, the camera may pick up some of the light as white, but it's really all green. And that will probably be the case with all colors. I'm going to remove the fiber optic tree and use the prismatic film. Again, there are similar results, but now we have green light instead of red. And actually, some of it looks blue or white to the camera. 77 is Color Selector Blue. We're going to move the 2 snap wire and place it between these 2 points, E and F. And we will turn on the slide switch, and now we have a blue light. Here's what it looks like through the fiber optic tree. And now we will remove it and use the prismatic film. It's pretty bright, this particular color. And even though the light scatters, it might be hard to see due to the glare. You can see all the different particles that are evenly scattered out. 78 is Color Selector Cyan. We're using the previous circuit, but we are adding a 2 snap wire between points C and D, in addition to the one across points C and E and F. Turn on the slide switch, and now the LED is cyan. Cyan is like a light blue, and perhaps to the camera it may not be that different from the regular blue shown earlier, but it is indeed cyan. It's pretty bright as well. Light particles scatter out. Now note that this is one of the 2 secondary colors that are made when you combine 2 others. In this case, you are mixing blue and green. Project 79 is Color Selector Yellow. We are going to add a 2 snap wire between points A and B after we remove it from points E and F. Now we're going to have a yellow color, which is a combination of red and green. Red and green makes yellow. And you might actually notice some red and actually it's visible to your eyes as well as the camera. You might see green as well, at least at the bottom of the fiber optic tree, because after all, green and red are the two colors that make yellow. Let's view this through the prismatic film now. Now the LED may look red to the camera, but it's really yellow. Look at those particles. It's much easier, both to the camera and your eyes, to notice the colors that make yellow. Zoom in and out a little bit. And the light seems to project very far as well. For Project 80, we're now going to do purple, and we put double snap wires between points A and B and E and F. I mistakenly put one in the middle. Now we have purple, which is a combination of red and blue. And we can view this through the prismatic film. And what do you see? In addition to the main purple light, it looks like you also see red and blue, which were the two, once again, the two colors that make purple. The light seems to extend pretty far. Finally, for Project 81, we have white. We are going to insert double snap wires on between all these points and turn on the slide switch. Now, even though the light may appear to be purple and blue, it's actually white. And it is the combination of all three primary colors: red, blue, and green. Even to your eyes, it looks like there's a lot of purple. But it's probably not perfect at mixing the colors, so that's why you might see it as like a very light blue without any attachments. Now let's view it through the prismatic film. And if you look carefully, you can see all three primary colors.